Rising students. This is Mrs. A, and I love math. And we are here with lesson 17 in your Saxon Course 3 book. We're talking about rounding and estimating, and they are not the same thing. Okay, so when we round, we will generally round a whole number up to a near number that ends in a 0 or maybe 0, 0 or possibly 0, 0, 0. Now, the issue is not left up to your discretion usually. Usually they will tell you which digit to round to. So here is an example. 188 could be rounded to 190 if you are rounding to the nearest 10. Or it could be rounded to 200 if you are rounding to the nearest 100. So normally your book or your problem will tell you which one you are rounding to. So in example 1, we are told to round that big number to the nearest 100,000. So the first really big job is to find out which place is the 100,000s place. So remember, this is the thousands. We go ones, tens, hundreds, thousands, 10,000s, 100,000s. So this is the place that we are going to round to. We always look at the number right after it. The number after it is an 8, and an 8 is larger than a 5. 5 or above, we round up. And if it's less than 5, we round down. So since it's an 8, we're going to round up, meaning that this one is going to go to 5, and everything else will become zeros. So let's do that. Let's make this one a 5. And then everything else goes to zeros because they told, oops, I lost the place there. 0, 0, 0. And that is 1,500,000. And we did that one correctly because we went to the number we're looking to round to. We looked at the number after it. Since it was an 8, we said, oh, I've got to make this number go up and then replace with zeros. Pretty cool, huh? Okay, so here we have the next example, which says round 3.14159 to 2 decimal places. Now, remember, let's practice reading that decimal correctly, which very often we don't read it correctly, but we should know how to read it correctly. Okay, so this is the tenths, hundredths, thousandths, 10,000ths, 100,000ths place. So we would say 3 and 14,159 100,000ths. Okay, and we're rounding it to 2 decimal places, which will be much easier to read. So here is 2 decimal places. So I usually, when I'm instructing, I will tell you to put a little line under the number that you're to round it to, and then always look at the next one. It's a 1. 1 is low, it's below 5. We're going to round down, which means 3.14 is going to stay, and those are just going to fall off. Now, why didn't I replace those with zeros? Because they're after the decimal, and anytime we have zeros after the decimal that are after any other number besides 0, then we can just let them fall off. They're insignificant, which means we don't have to have them there. Okay, so any zeros before the decimal on the left of the decimal are not insignificant. They're very significant because they're holding a place. But if you have zeros to the right of a decimal and there's no other number that it's holding the place for, you can just drop them off. They are unimportant. So now let's read our new number correctly. 3 and 1400ths is much easier to read. Okay, so now we have 2 numbers in the next example that we're going to round to the nearest whole number. Okay, so we have 13 and 5/12. So the key is 5/12 greater than or less than a half? Well, a half would be 6/12. So 5/12 is less than a half, so we're going to round down. So the answer to the first one is just 13. 13.512 is 13 and 512 thousandths, and 5 would be a half, but 0.5 would be a half. 0.512 is greater than a half, so we're going to round this number up to 14. Remember, we're going to the nearest whole number. So we're going to round 5 up. We're going to say that's a 14 there. The next one says, estimate. An estimation is different from rounding. Determine an approximate value. Estimate the length of one wall of your classroom in feet. Okay, so now I thought they had a very good discussion of estimation. So I'm going to help you understand estimation a little bit just by reading a little bit about what they say about estimating as opposed to rounding. Rounding, there's a very specific pattern that you have to follow. Estimating could be done several ways. I might estimate entirely different than the way you. I should come up with a similar answer if we're both estimating correctly. Listen to this. It says we make estimates in our activities throughout the day. In a baseball game, for example, the batter estimates the speed and location of the pitch and swings the bat to arrive at the expected location at just the right time. The awaiting fielder hears the crack of the bat and in a split second estimates the ball's trajectory and begins moving to the point where the ball is expected to land. Both players adjust their estimates as they visually gather more information about the path of the baseball. The estimates that we make in athletics are extremely complex, yet with practice we perform them with ease. We can also become proficient at estimating measures and calculations as we practice these skills. Now, this is the suggestion that they had about estimating the wall length that I just read to you. There are a variety of ways to estimate a length of several feet. Some people walk a distance using big steps, counting 3 feet, 1 yard to a step. Now, if you had a big stride like Mr. Aldridge, you would do that. Okay, I don't have that big a stride, and most of you don't have that big a stride. Okay, other people will use a reference such as a door, which is about 7 feet high, to visually form an estimate. So you can kind of compare with your eyes. The height of a door is 7 feet. The width of a door is usually about 3 feet. Okay, so you can kind of get a mental estimate that way. Okay, so they're challenging us to make an estimate of our classroom. So we'll have to do that when we get in there. We'll have to pause the video and check. Okay, now it says estimating calculations helps us to decide if the answer is reasonable. Now in this way we're going to use estimation a lot, and you're going to hear Mrs. A always telling you to estimate your answer. For example, suppose we are calculating the cost of 48 square yards of carpeting, priced at $28.95 per square yard. We could round the quantity of carpet to, instead of 48, we could round it to 50 square yards to make that calculation easier. And then we could take the $28.95 and round it to 30. And it would be much easier to multiply 50 times 30 than it would to multiply 48 times $28.95. Now, we're not getting an exact answer, But a lot of times we don't need an exact answer. We're just looking for a ballpark figure to say, can I afford that? Or should I maybe not do that right now? Okay, so let's look at example 5. If I did not help you figure out the size of our classroom, tell me that I should do that right now. Okay, so I'm going to read this problem to you first. It says Ivan wants to tile the floor of a kitchen that is 12 feet long and 8 feet wide. The installed tile is $7.89 per square foot. Ivan calculates that the cost of the floor is $315.80. Is Ivan's calculation reasonable? Okay, now, are they asking us to do all that math, or are they saying that Ivan already did the math? Okay, so we're just going to estimate to see if his price is reasonable. So here we've got 8 times 12, and 8 times 12 is 96. Okay, so 8 times 12 is 96, which is real close to 100 square feet. So we could use 100 square feet. Now I use this little symbol. This is your approximation symbol. Approximately 100 square feet. Okay, and remember that the $7.89 is for every square foot. So let's make that $8. Okay, so 100 square feet times $8. Wouldn't that be 800 square feet? 800 square feet is nowhere close to $315.60. I think Ivan needs to do his math again. Don't you think so? I do. Okay, so basically when you look, it says it is not reasonable, and they estimated it just the same way we did. He needs to do his math again. Okay, so this is example 6. It says Richard is paid $11.85 per hour. About how much money does he earn in a year, which is 52 weeks, if he works 40 hours per week? Okay, now there's several ways that we could do that, but let's round this one up to 12. Now, I rounded to a whole number. Okay, so I could say round. I rounded to the nearest whole number. Okay, and then 52 is hard to calculate with, but what if we made it 50? Besides, isn't he probably going to get a few days off, maybe sometime at Christmas or Thanksgiving? So 50 is a good estimate. Very few people work every week of the year. Okay, so he's probably going to get a week or two off, and then he gets to have 50, all right? And 40 is a pretty easy number to calculate with. Now, I'm going to make my math even easier. I'm going to multiply 50 times 40 first. You hear my cat going, wow, wow. Okay, 50 times 40. 5 times 4 is 20, but then we're going to tack on the 2 zeros. 2,000 times 12. Okay, which is going to be $24,000. Now, that is not exact, but it is a good estimate of about how much money he will be making throughout the course of the year. Now we're ready for our practice problems. In A, we're to take this number, and they had commas in their number, so I'm going to put commas in my number. We're to round it to the nearest 100,000. So remember, we're going to put a little line underneath the 100,000s place. Okay, so this is ones, tens, hundreds, 1,000, 10,000, 100,000. I look at the number right to the right of it. I'm going to look at the 8. 8 is bigger than 5. I round up. So now that's going to become a 2. And everything else is going to become a 0 after it. So 1, 2, 0, 0, 0, 0, 0. And that is the answer to A. Okay, so that would be what? 1,200,000 is rounded from that number up. Okay, so now we have a decimal. And we're going to round this 5 decimal places to 4 decimal places. So 1, 2, 3, 4. We have one digit after it. It's a 9, which means we round up 5 or greater than 5 or 5. We round up. That becomes a 6. So we're going to have 3.1416. And remember, we don't need to put a 0 there. When we round that up, see, we're really rounding that up to 60, but that is not a significant 0. So we just leave it off. And there you have the correct answer. Letter C, we're going to round 2 and 19. So this is $2 and 19 9/10 cents. Okay, why did they do that at gas stations? Just go ahead and bump it up because it doesn't fool anybody, right? So basically that 9/10 is almost a whole. It's definitely bigger than a half. Means we're going to round this one up. And so the 19 is going to become 20. And we're going to have $2.20 per gallon. Okay, so now we're on D, and it says estimate the height of the ceiling in your classroom in meters and in feet. Now remember, meters, a meter is about 39 inches. Okay, so a meter is 3 feet and about 3 inches. Okay, so it's not exactly 39 inches, but close enough. So if we were going to do our classroom, we'll have to look when we get there tomorrow, but I'm just going to do this room that I'm in right now. So let's look at, you see that door behind me? And up above that door, it looks like it's bigger than a foot. I'm going to give it 1.5 feet. Okay, so I'm going to say I have 1.5 feet plus the 7 feet of the door. So I'm going to say that my height of my ceiling is about 8.5 feet. Okay, so now we could estimate that about, it says meters, so 8 feet. If a meter is a little over a yard, 3 feet, so we could have 3 and a little bit plus 3 and a little bit plus 3 and a little bit. That would be more than 8 feet. So why don't we say maybe 2.5 meters? Okay, maybe 2.5 meters. Because when we're estimating, we're not going to be exact. Okay, we're not trying to do the math exactly. I know it's not quite 3 meters. And I know it's more than 2 meters. Because 2 meters would be closer to 6.5 feet, maybe. So 6.5 feet, my door is 7 feet. So I'm going to say 2.5 meters. Okay, and then it says, and we're supposed to do it in feet and in feet. So 8.5 feet, 2.5 meters. That's a good estimate. Okay, estimate is definitely not trying to get nitty gritty on the math. And then estimate the sum of these two numbers. Now, when I'm estimating the sum, I'm going to try to make this easy on myself. I'm not looking for an exact. I'm going to round to the hundreds place. Okay, now could I round to the thousands place? I could very easily round to the thousands place. I'm going to round to, let's say, okay, 39. Okay, and then this one, oh, this one's going to be 53 because that's bigger than 5. So if I'm going to get a better estimate if I do that than if I round to the thousands place. Okay, if I do this, then I'm going to get 12, 8, 9, 9,200. Okay, it's an estimate. Or I could round or estimate to the thousands place. So that's going to be about 4,000. That's going to be round down because that's a 2 to the 5,000. And that's going to be 9,000. 9,000 is what I got when I rounded it to the thousands place. 9,200 is what I got when I rounded it to the hundreds place. Which one is more accurate? Well, this one's more accurate because I made a closer estimate by rounding it to the hundreds place instead of to the thousands place. It depends on whether I really need to be that accurate. Okay, if I only need to have a ballpark figure, I would do the thousands because it's easier. But if I need a little bit more accurate, then I would round to the hundreds place to make it a little bit more accurate. All right, this one, we really get nitty gritty with this one. Okay, this one is F, and it says estimate the product of 12 3/8 and 9.75 by rounding each number to the nearest whole number before multiplying. All right, so since 3/8 is less than a half, I will round down to 12. 9.75, 7 is greater than 5, so I'm going to round this one up. You really get a much better estimate if one of the numbers goes down and one of the numbers goes up. It kind of evens out, doesn't it? So you're going to get a better estimate if one of the numbers goes down and one of the numbers goes up than if you had both of them go down or both of them go up. If both of them went down, you would get your estimate would be lower than your real price by a good bit. Okay, if both of them go up, then your estimate will be higher than your real price. But when one goes down and one goes up, then you've got a better estimate, don't you? Because it's going to be somewhere in the middle. Okay, so we're going to have 12 times 10 or 120. All right, so when you did the real math, you could, the exact calculation, you could match it with 120, which was very easy to get, and see if your answer is reasonable. All right, so now we're on G, and G says Gus works 39 hours for $9.85 per hour. He calculates that his weekly paycheck should be about $38,415. What is a reasonable estimate of what Gus earns? How do you suppose Gus arrived at his calculation? Okay, so let's look at it. He is getting about $10 an hour, right? So wouldn't we take his 39 hours and multiply by 10 to get an estimate? And it's going to be a high estimate, isn't it? So when we multiply by 10, we just tack on another 0. 390. He's estimating 38,415. Oh my goodness, what did he do? He came up with 2 extra. I think he actually forgot to put his decimal back in, don't you think? He did. Should have multiplied and then put his decimal in. I think he left his decimal out. That was a pretty big mistake. He thought he had 38,000 when he only had 390. That's got to be disappointing, right? Okay, so look at H. A rectangular room is 11 3/4 feet long and 10 1/2 feet wide. Grace calculated the area to be about 124 square feet. Explain why her calculation is not reasonable. Okay, so this is what she calculated. Is or is not reasonable. They didn't say is not. Is or is not. So we're going to make this 11 3/4 is close to 12. And 10 1/2, half rounds up, doesn't it? So we'll make that 11. 12 times 11, if you remember your math facts, is 132. Okay, and we rounded that one up and that one up. 132 is a little bit bigger than 124, but we expected a little bit bigger because we rounded up on both. So I'm saying yes, her answer is reasonable, isn't it? Okay, now let's look at I. And it says it is 6:05 p.m. and Eduardo is driving to Dallas. If he is 150 miles away and driving at an average speed of 62 miles per hour, is it reasonable that he can reach Dallas by 9 o'clock p.m.? Explain your answer. Okay, so if we start, let's just start at 6. Okay, and then because we're estimating, he's got to drive 157 miles. And let's take the 62 and make it 60 miles an hour. Okay, a 60 miles an hour is a mile a minute because there's 60 minutes in an hour. So he's going about a mile a minute. So 157 is going to be 157 minutes. Okay, we could make that 160. Okay, so 160 minutes. Now, how many minutes in an hour? How many times does 60 go into 160? We know 2 60s is 120, and 3 60s would be 180. 180 would be 3 hours. 3 hours from 6 to 9 o'clock. He can get there on time, can he? He can get there because he really only has about 2 hours and 40 minutes to drive instead of 3 hours to drive. So, and he's going faster than we gave him. Okay, so he should have no problem getting there within the 3 hours, should he? Isn't estimation fun? Okay, so now it's time for us to start our written practice. Number 1 says, in the orchard there were 10 rows with 12 trees in each row. How many trees were in the orchard? Okay, so if we have 10 rows and 12 trees in each row, isn't that multiplication? We're going to have 10 times 12 equals 120 trees in the orchard. That cat. My goodness. Number 2. At 8 a.m., it was 57 degrees Fahrenheit, and at 1 p.m., it was 72 degrees Fahrenheit. By how many degrees did the temperature change between 8 a.m. and 1 p.m.? Isn't this just a simple subtraction problem? Okay, so we're going to put 72 minus 57. Won't that tell us how much change there was in between? How many degrees? So 12 take away 7. We're going to have to borrow here to make that 6. 12 take away 7 is 5. 6 take away 5 is 1. 15 degrees is the temperature change. This one's fun. This is number 3. Write a sequence of numbers with 1 as the first term and a constant difference of 2 between the terms. Now, they did not tell me how long to make the sequence. But if a difference of 2 is in between 1 plus 2 is 3, plus 2 is 5, plus 2 is 7, plus 2 is 9. And I have the sequence of odd numbers because it just keeps on going. They didn't tell me when to stop. Number 4 says, Brandon said that 48 yards is equal to the length in length to 4 feet. Explain why his statement is unreasonable. 48 yards is equal to how many feet? Well, we know that every yard has 3 feet. So wouldn't 48 times 3 be what we're looking at? Not 4, right? It can't be 4 because yards are bigger than feet by each yard is 3 feet. So 48 times 3, 8 times 3 is 24. I need to write it down here. 24. 4 times 3 is 12. 13, 14. 144 feet, not 4 feet. That's just ridiculous. Okay, number 5 and number 6 are dealing with our squares and our square roots. 11 squared is the same thing as 11 times 11. Hopefully you know your math facts. That's 121. Oh boy, since they did that one for us, then we know the square root of 121 is 11, because the square root is the number that we would have to square in order to get the number underneath the radicand. Last problem. I'm doing all the way up to number 7 for you. I hope you're watching your video. Okay, so 1/2 plus 3/4. We need a common denominator, but 2 goes into 4. So let's change the 1/2 to a equivalent fraction that has a 4 on the bottom. So I'm going to multiply by 2 over 2, which is 1, and I get 2/4 plus 3/4 is 5/4. But I can't leave it as 5/4 because that's improper. So I'm going to turn 5/4 into a mixed number. 5 divided by 4 is 1 whole, leaving 1/4 left. 1 1/4 is the answer. We have done all of your examples, all of your practice, and 7 of your written problems. So certainly, I should have no one late with this homework assignment. This is Mrs. A, and may God bless your day.